What's up, guys? In this video, we're going to explore evaluating quadratic functions. And basically what we're going to do is we're going to work through kind of numbers into variables, into variable expressions. So I've hand-selected 5 examples that I want to go through to help you understand how to evaluate functions for a value. Hope you enjoy.
So in this example, again, we're just doing the same thing, but this one's a little bit more difficult because now I'm not only finding the value, it's not like last one, it was x was equal to 5, right? So you just put in 5 in for x. But now I have an expression, all right? Which is, becomes a little bit difficult, but the process is going to be exactly the same thing. Now, the value of x that we're trying to evaluate for is 3x minus 1. So I'm going to replace x with 3x minus 1. Notice that I'm using parentheses here, all right, to represent that I'm plugging one value in for the other. Apply distributive property. And then the value of my function at 3x minus 1 is going to equal 6x minus 3. OK?
So what I want this to do for this problem is to evaluate g of x equals negative x squared. And I want to evaluate, instead of for my terms of x, I want to evaluate for what is going to be the value of my function g for a plus 1. So this represents the value of my function at x. So to find the value of the function of a plus 1, I'm going to have to plug in my a plus 1 into my function, which is x, negative x squared. So I have a negative a plus 1 squared. And then here, what I can do is I can represent this represents a plus 1 squared. So I have negative a plus 1 times a plus 1. Then, using my FOIL techniques, I multiply the front two terms, which is going to give me an a squared first. Then I multiply the outer terms, which will give me a times 1, which is a. My inner terms, which again will give me a. And then 1 times 1, my last terms give me 1. I can combine my middle terms. Negative a squared plus 2a plus 1. And then my last step is now to distribute my negative sign to all of my 3 terms. So I end up with a negative a squared minus 2a minus 1. So g of a plus 1 is equal to a negative a squared minus 2a minus 1. And that's how you evaluate a function for when you have g of a plus 1.
I think everybody then feels pretty good about if I was just going to do f of 2, then everybody at least understands that whatever is inside those parentheses is now my new input value, and you're plugging those in. OK, Erica? So you have 2 times 2 squared minus 3 times 2. 2 squared is 4. 4 times 2 is 8. So therefore, it's 8 minus 6, which equals 2. Everybody feels pretty comfortable with that? Well, ladies and gentlemen, you're just following the exact same steps. You're just doing f of x plus 2 is just going to be 2 times x plus 2 squared minus 3 times x plus 2. Now, remember what we did. Was it last class period? Yeah, last class period. We practiced multiplying, right? And remember we multiplied binomials. Oh, I erased it, but it was up there. This is a binomial squared. You guys should know how to multiply a binomial squared. You don't need to do FOIL or all the crazy stuff. X squared plus 4x plus 4 minus 3 times x plus 2. Now you apply distributive property. 2x squared plus 8x plus 8 minus 3x minus 6. And then you combine like terms. Those are like terms. Those are like terms. 2x squared plus 5x plus 2. Right? Yes? X represents our input. Here is our function. So if our input is now x minus h rather than x, I need to replace all of my x variables now with x minus h. And make sure you also keep your parenthesis. OK? So now, again, by following the order of operations, I know that I need to square. I need to apply the power before I do any multiplication or division. A big common mistake that students will do is they'll multiply the 2 inside of that before squaring. Remember PEMDAS, parentheses, exponent. So we need to do the powers here first. All right, so I have x minus h squared, which fortunately for me, I realize is a perfect, it's a binomial squared, right? So I can do this in my head based on those rules that I wrote down there before. So therefore, that's going to give me x squared minus 2xh plus h squared. And then here, I can just apply distributive property, minus 3x plus 3h. I'll apply distributive property again over here. 2x squared minus 4xh plus 2h squared minus 3x plus 3h. And then I just look for any common terms, which I don't have any common terms, do I? Nope. So therefore, I'll just kind of group these together. Just like that. There you go. Done.